SOF NSO Electric Circuits Previous Year Questions and Solution for Class 6 and 7. Question number 1. The given circuit shows an electric cell connected to a bulb through conducting wires. Identify the direction of current flow in the circuit. An electric circuit is formed when a conductive path is created to allow electric charge to continuously move. This continuous movement of electric charge through the conductors of a circuit is known as current. Electric current is always said to flow from positive terminal to the negative terminal. Here the positive terminal is S and the negative terminal is P. So it will go from S, R, Q and then P. Question number 2. Match the column 1 with column 2 and select the correct option for the given codes. Bulb. A bulb is correctly matched with the first option in column 2. Here we are correctly matching the components of a circuit with their correct symbols. If we do that, we'll get the answer as option number B. But just for your knowledge, let us look into some other symbols. Open switch can also be portrayed like this. It is similar for a closed switch. For a resistor, variable resistor, galvanometer, ammeter and voltmeter. Question number 3. In the given circuit diagram, S1, S2 and S3 are switches. Which of the following switch combination is correct for the lamp to glow? For the lamp to glow, S3 should be closed and either S1 or S2 should be closed, or both S1 and S2 can be closed together. So the correct option is option D. Question number 4. Which of the following diagram represents a short circuit? A short circuit offers almost zero resistance. Since current prefers the path with the least resistance, nearly all the current bypasses any other component such as resistor and flows through the short-circuited wire. Here option B shows a short-circuited path. Question number 5. In which of the following circuits will the bulb glow? Here option A is a short circuit. In option B, the circuit is complete, so the bulb will glow. In other options, the circuit is not closed, so there is no possibility that the bulb will glow. Question number 6. In the given figure, which of the following switches need to be closed to change electric energy to sound energy only? Here, the doorbell converts electrical energy into sound energy, so switches P, R and T should be closed. Question number 7. The diagram shows the front view of the circuit board. There are wires connected behind the circuit board which allow the bulb to glow. Which are the possible circuit points? Points in an electric circuit where two or more components such as resistors, capacitors or transistors are connected are called as junctures. Here, point P, T and S should be connected to form a closed circuit. Question number 8. Which of the following statements about the circuit is /R incorrect? 1. Lamp 1 will light up when either L2 or L3 are lighted. We can also say that lamp L1 will light up when either S2 or S3 is closed. So this option is correct. Electricity will flow only when all the switches are closed. Electricity will flow if either S2 or S3 is closed. So this statement is false. Third one, electricity will flow as long as any one of the switches is closed. Electricity will flow if either S2 or S3 is closed. If only S1 is closed, electricity will not flow. So this option is also wrong. They have asked the incorrect option, which is B. Question number 9. The given figure shows a circuit which contains two identical lamps. When the switch is closed, which of the following statements best describes what happened to lamp P and Q? Before the switch is closed, the current flows from lamp P, then through lamp Q and back to the battery. Both lamps P and Q are on because they are receiving current. After the switch is closed, a new low resistance path is created around lamp P. Since current always flows the path of least resistance, almost all the current will flow through the closed switch instead of lamp P. As a result, lamp P receives almost no current and turns off, and all the current from the battery flows only through lamp Q. Lamp Q is now therefore brighter than before. So the correct option is B option, that is P does not light up but Q is brighter than before. Question number 10. Mishra, a class 7 student, suggests the given circuit setup. Her teacher said that this circuit is unsafe because this circuit given in the picture is unsafe because the fuse is placed on the neutral wire instead of the live wire. The fuse is meant to break the circuit when excessive current flows, preventing overheating and fire hazards. Since it's on a neutral wire, if the fuse blows, the live wire still remains connected to the switch and the bulb. Therefore, the correct option is the B option. The fuse is wrongly connected. That is why the circuit is unsafe. Question number 11. The given diagram shows an electrical appliance with a metal box indicated by dotted lines connected to the main supply. Where should the fuse be placed? The fuse should be placed on the live wire, that is the P point. Here's a recap of series and parallel circuits. Keeping that in mind, let us solve the other questions. Question 12. These are 4 identical bulbs, B1, B2, B3 and B4 in the given circuit. Which bulb has the maximum brightness? In a parallel circuit, each branch gets the full voltage of the battery. Here, B4 is parallel with battery and B1, B2 and B3 are in series connection with battery. Since B4 is alone in its branch, it gets full voltage, making it more brighter than the others. The bulb B1, B2 and B3 are in series, so the voltage is divided among them, making them dimmer. So now the answer is B4. B4 will have the maximum brightness. Question number 13. 3 identical lamps L1, L2 and L3 are connected as shown in the given circuit. Which combination of the switches make the lamp L1 glow brightest among the 3 lamps? When current passes through the filament, it resists the flow of electricity, causing it to heat up. The filament reaches high temperatures and emits visible light. Their resistance follows Ohm's law. V is equal to IR, where V is voltage, I is equal to current and R is resistance. If S1 is closed and S2 is open, L2 and L3 are in series, increasing their total resistance and limiting the current passing through them. This results in more voltage drop across L1, making it brighter. We know that total resistance increases in a series circuit because total resistance in a series circuit is the addition of all the resistance in the circuit. To make L1 glow the brightest, S1 should be closed and S2 should be open. This ensures that L2 and L3 receive less current, maximizing the voltage across L1. So the correct option is the B option. S1 should be closed and S2 should be open. Question number 14. 4 similar identical lamps are connected to a battery as shown in the given diagram. Each lamp operates at normal brightness and the ammeter of negligible resistance registers a steady current. The filament of one of the lamp breaks. What happens to the ammeter reading and to the brightness of the remaining lamps? The total current through the ammeter is the sum of the currents through all the bulbs, since they are in parallel connection. If one bulb's filament breaks, the current through that branch drops to 0, but the remaining bulbs continue to operate normally. The total current flowing through the circuit decreases, and the ammeter reading will decrease accordingly. The remaining bulbs will still receive the same voltage because they are in parallel connection. Since brightness depends on the voltage and not the number of bulbs in a parallel circuit, the remaining bulbs will glow with the same brightness as before. So the answer is the B option. Ammeter reading will decrease and the lamp's brightness will remain unchanged. Question number 15. The electrical circuit shown here was set up by Ramesh. He placed a 6 cm copper bar X in the electrical circuit. He closed the switch and observed the brightness of the bulb. Ramesh then repeated the experiment, each time using copper bars of different length, 8 cm, 12 cm, 15 cm. The aim of his experiment was adding a resistance in a series with a light bulb would decrease the brightness of the bulb because it increases the total resistance in the circuit, thereby reducing the current flowing through the bulb, which directly impacts its brightness. Essentially, the bulb receives less power due to the added resistance. So, the answer is the C option. To find out if the length of the bars affects the brightness of the bulb, because he is changing the length of the copper wire. Let us see how the resistance of a circuit is affected by the length and width of metal wires. Adding a resistor in a series equals to decreasing brightness of a bulb. Using a long copper wire is equal to increasing resistance and also decreases brightness. Knowing this in mind, let us continue with the other questions. Question number 16. 4 identical bulbs are connected in a circuit as shown here. When the switch S is closed, which of the bulbs will light up? The eraser is an insulator. It will block the flow of current, preventing the circuit from closing. This means no current will flow. None of the bulbs B1, B2, B3 and B4 will light up. Therefore, the correct option is none of these. Question number 17. In the given diagram, the cheese starts to melt when the switch is on. What can X be? The cheese will melt when the material X gets heated when electricity passes through it. Material X should be a conductor. Silver and copper are conductors of electricity. So the correct option is option number A. Question number 18. A circuit consists of battery E, a resistance R and 2 light bulbs X and Y are connected as shown in the given figure. If the filament of the bulb X burns out, then select the correct statement about the light bulb Y. In a parallel circuit, each bulb has its own independent path to the battery. If one bulb burns out or disconnects, the circuit for the other bulb remains complete, allowing it to continue receiving power. The voltage across the working bulb remains unchanged, so its brightness is unaffected. Therefore, the answer is option number D. Its brightness does not change. Question number 19. Bulb 1 and bulb 2 are connected in a series as shown in the given figure. What will happen to the brightness of these two bulbs when a third identical bulb is connected across bulb 1 as shown in the given figure 2? When bulb 3 is connected in a parallel circuit with bulb 1, the effective resistance of the parallel combination is lower than the resistance of bulb 1 alone because adding parallel branches reduces total resistance. If bulb 3 has lower resistance than bulb 1, it will draw more current, reducing the current through bulb 1. As a result, the brightness of bulb 1 decreases. Bulb 2 remains in series with the entire parallel combination. Since the total circuit resistance decreases, the total current supplied by the battery increases. Because bulb 2 is in series with the increased total current, the current through bulb 2 also increases. Since power is proportional to the square of the current, that is, P is equal to I square R, bulb 2 becomes brighter. Therefore, the correct option is the D option. Bulb 1 becomes dimmer and bulb 2 becomes brighter. Question number 20. Which of the following statements is correct for the given circuit diagram? A. To convert the electrical energy into heat energy, only switch R should be closed. To convert the electrical energy into heat energy, switch R, P and S should be closed. So this statement is false. B. Minimum number of switches need to be closed for conversion of electrical energy to sound energy is 2. This is also false. To convert electrical energy to sound energy, we need to close switch P, S and Q. C. To convert the electrical energy to light energy, only switches S and Q should be closed. This is also false. To convert the electrical energy into light energy, switch P should be closed. D. If electrical energy is being converted to sound energy and heat energy, then conversion to light energy is also taking place. Yes, to convert the electrical energy into sound energy and heat energy, all the switches must be closed. If we close all the switches, the bulb will also glow, therefore converting electrical energy into light energy. So the correct option is option number D. Question number 21. The diagram shows three identical light bulbs X, Y and Z connected in a circuit. What will happen to the brightness of the bulbs if a similar bulb is connected in the series with bulb X? When another bulb is added in the series X, the total resistance in that branch increases. The increased resistance in X's branch causes less current to flow through it. As a result, the brightness of X decreases. Since Y is in a parallel with X and X's branch now has higher resistance, more current will flow through Y's branch because current prefers the path of least resistance. As a result, Y will get more current and becomes brighter. The total resistance of the circuit increases because the added bulb in X's branch increases overall resistance. This reduces the total current supplied by the battery. Since Z is in series with entire circuit, Z also receives less current and becomes dimmer. Therefore, the correct option is the B option. X becomes dimmer, Y brighter and Z also dimmer. Question number 22. A circuit diagram is shown here. Which of the switches must be closed so that only bulb 1 glows? The switches P, R and T should be closed so that only one bulb lights up. Question number 23. 5 lamps L1, L2, L3, L4 and L5 and 3 different types of materials M1, M2 and M3 are used in the circuit shown. If L2, L3 and L4 are the only lamps that light up, then which of the following conclusions can be made? The conclusion that can be made is the D option. Only M1 and M3 are conductors of electricity. Question number 24. Consider 4 identical bulbs B1, B2, B3 and B4. These are connected in the manner as shown in the given figure. When one of the 4 bulbs B3 has blown off, then consider the following statements. Statement 1. Brightness of the bulbs B1, B2 and B4 increases. Statement 2. Voltage across B1 and B4 will become equal. In a series circuit, the current flows through all the components sequentially. If B3 is blown out, open circuit, no current can pass through B1, B3 and B4. This means the series circuit is interrupted and B1, B4 also becomes inactive. As a result, the parallel circuit containing B1 and B2 cannot function because B1 is inactive. The entire circuit will stop functioning because of the failure of B3 in the series connection. Interrupts the flow of current throughout the circuit. So, therefore, the D option, both statement 1 and 2 are false. Question number 25. Consider the 4 diagrams. The correct option for the brightness of the bulbs in increasing order is, assume all the cells and bulbs are identical. When batteries are connected in a series, their voltage adds up and gives higher voltage. So, bulb glows brighter when connected to series connected batteries. In a parallel connection, voltage remains the same as a single battery. Bulb connected to the parallel batteries glows normally as it receives the same voltage but with longer battery life. The correct option for the brightness of the bulbs in increasing order is 2, 3, 4, 1. That is the B option. Question number 26. Consider a 3 voltage cell. It is connected across 2 uniform resistant wires PQ and RS of resistance 1 ohm and 2 ohm respectively. Length of PQ is 3 cm and length of RS is 6 cm. A voltmeter with one end fixed at point P and the other end connected with a jockey slides from point R to point S. Which of the following diagram represents reading of voltmeter as the jockey slides? X is the length from R to J. A voltmeter measures voltage and it allows almost no current to pass through it. We know that using a longer resistor increases the resistance of the circuit. However, the voltage is directly proportional to resistance when the current remains constant. According to Ohm's law, V is equal to IR. Current in the circuit using Ohm's law is equal to 1 ampere. Voltage drop across PQ taking X is equal to 0 will be 1 voltage. Voltage drop at S is equal to taking X is equal to 6 is equal to 3 voltage. The voltmeter reading starts at 1 volt at R. As jockey moves from R to S, the reading increases linearly. At S, the voltmeter reads 3 volts. Thus, the voltmeter reading increases linearly from 1 volt to 3 volt as jockey moves from R to S. The correct graph which represents this is the D option. Question number 27. A heater, a fan and a bulb are connected to the 15-volt battery as shown in the given figure. The fan with resistance R has a potential difference of 6 volts across it and a current of 3 ampere is flowing through the fan. The bulb has a current of 2 ampere flowing through it. Select the correct statements. From the circuit, the fan and heater are in series and the bulb branches off into parallel. Using Ohm's law, let us calculate fan's current, fan's voltage, fan's resistance and bulb's current, bulb voltage and bulb resistance. Heater current, heater voltage and heater resistance. Using this, let us check which statement is correct. Given fan's resistance is equal to 2 ohms, which is equal to R. The voltage across the bulb is 6 volts. Yes, this is correct. And the resistance is 2R. Here the value of R is equal to 2 ohms. Given the resistance of bulb is equal to 4 ohms, not 3 ohms. Given resistance of bulb, they have said it as 4 ohms, but R resistance is 3 ohms. So this is wrong. B. The voltage across the bulb is 6 voltage. Yes, this is correct. And its resistance is 3 by 2 R. Given the resistance of bulb is 3 by 2 into R, which is equivalent to R resistance. So it is correct. C. The voltage across the heater is 9 voltage. Yes, this is true. And its resistance is 2R. Here the value of R is equal to 2 ohms. Given the resistor of heater is 2 into R, which is equal to 4 ohms. But here we have the resistance as 9 by 5 ohms. So this is wrong. In the D option, the voltage across the heater is 9 volts. Yes, this is correct. And its resistance is 9 by 10 Rs. Here the value of R is equal to 2 ohms. Given the resistance of heater is 9 by 10 into R, which is equal to 9 by 5 ohms, which is correct, as R resistance is equal to 9 by 5 ohms. So the only correct option is the B option. Question number 28. The given figure shows the inside view of a torch. Identify the wrong statements regarding the marked parts and its respective descriptions. 1. Part that either breaks the circuit or completes it is actually the metal switch, which is correct. Second, part which converts chemical energy into electrical energy, which is the cell. Yes, it is correct. Third, part that reflects light is the third part. Yes, this is also correct. Fourth, negative terminal of a cell. 4. Wrong. It is actually the positive terminal of a cell. Positive terminal of a electrical cell. 5. No, this is wrong because it is the negative terminal of the cell. They have asked for the wrong statements and only 4th and 5th statement is wrong. So the correct option is the D option. That's it for this video. Make sure to subscribe, hit that like button, turn on post notifications so that you guys never miss out on a video that I upload. And I'll see y'all next time. Goodbye.